Having our work mounted rigidly and solid in the mill vise or on the table is of extreme importance. If our workpiece is moving during the machining operation, our tolerances have just gone to heck in a handbasket. So we're going to show you some neat tips and tricks on how to properly mount the work using a variety of work holding methods. First, let's take a minute and talk about the old step clamp. That's an interesting design. Every machine shop is complete with a good set of step clamps. We'll show you on this particular round disc how we can attach this to the bed for proper machining. We've got T-slots that are threaded with a stud that we're going to slide into the T-slots on the mill bed. We'll space them accordingly. Mount our workpiece in the center. Now it's a good idea, you can either use a little piece of 3x5 index card or another piece of material. I like using a little piece of aluminum from time to time to support our step blocks on. I don't think it's a real good idea to be supporting those directly on the mill bed, and again, we don't want to be tightening them too tight, pulling up the T-slots, causing a deformation in our mill bed. Set our blocks up in this fashion. Again, it's very important when we're using a step block system that our clamping block, which is this piece, remains parallel to the bed. We don't want it in an elevated position as such where we're just simply clamping with the tip. This can deform the part we're working on, but it doesn't really put the adequate down pressure that we need to hold the part securely. Besides that, if we're trying to put our flange nut on the top of this angled surface, we're going to get minimal contact with the flange nut at that time, and it's going to try and push the clamp bar. So always adjust them to where they're parallel to the bed. Again, if we're working with a well-machined, ground, or polished piece of material, we can also take another piece of 3x5 cardstock, a piece of brass shim stock, and insert it underneath the nose of the hold-down clamp. This will protect our part while we're machining. It's always a good idea to have several clamps securing the workpiece. Very seldom can we get by with just one clamp depending upon the shape of the piece that we are machining. We want to hold it rigidly while the cutter is machining through the part. We don't want it to shift or rotate, scrapping that particular part. I like using flange nuts. You can see a flange nut is a nut that has a washer machined integral. Every now and then it is necessary to use an additional washer, either to space up and down where we have adequate threads or to give the proper clearance in order to be able to run our cutter or our quill by the part that we're machining. Make sure and have our studs close to the end of the clamp. We don't want them in the back there as we lose clamping pressure on the part. Move them up towards the forward edge. We'll bring our flange nuts down, and you probably want to torque them to 60-80 foot-pounds. Again, we don't have to try and pull the T-slots out of the mill bed, but we want to secure the part properly for adequate machining. Okay, so if we were going to hold that part, simply take our wrench, seat it down, and we're ready to go for the next machining operation. Step clamps, very invaluable. You can buy them from a variety of the wholesale houses. They're going to run you somewhere in the neighborhood of $80 to $100. They're a well addition to your machine shop accessories. Let's take a look at a little different application as well, and a mounting procedure that you want to keep in the back of your mind for those oddball projects that come in the shop. Here's a sample gauge. This is a real difficult part to hold. It's rather large in diameter, it's long, we've got a little flange on the base here, making it very difficult to hold. In this application, we would use a very low profile clamping arrangement, as in this fashion, on each side in order to hold it down. Okay, again, keep our clamping pads parallel to the bed. This has got a nice ground finish on it. I would recommend putting a piece of shim stock underneath the nose of the tool in order to protect our part. Another way that we can do it is to move our T-slots directly underneath and with a rather long stud come in from the top. Again, this will vary depending upon the type of machining application we have in mind. We can use a big washer, we can use a hold down of this fashion, put our flange nut on the top and hold that part securely to the bed. Okay, so these are a couple of good ways that we could hold an oddball part as we're displaying now. Also, another thing that's a trick that a lot of people overlook, and that is if we have a large round cylindrical part that we need to mount and dial in because we need to put a hole pattern in it or a series of slots, we can also use the T-slots themselves as a guide. Those T-slots are very carefully machined, and they're machined parallel with the mill bed. In this case, we've got a 3-inch bar of solid aluminum. We can mount that directly in our T-slot, okay, and that's going to align it. If we were to run a dial indicator down this edge, we would find that that's running extremely straight and ready to machine. Again, in this clamping operation, we would probably use our step blocks. We can come over the top with a little bit longer one in this fashion, okay, and clamp it directly to the bed. I would recommend putting our 3x5 index card underneath it if we want to. We don't want to scrounge down really tight and deform anything. Just good snug contact. Make sure that our top clamp, again, is parallel to the mill bed before we start to torque it down. By doing clamps on either side, we can securely hold the part, machine whatever slots, drill hole patterns, whatever the case may be for this specific part. All right, that pretty well concludes the use of the step clamp system. Now let's take a look at some other pieces of tooling that come in very handy in the machining operation. We've got a little miniature vise. This oftentimes I will use in conjunction with my large vise that's mounted directly on the mill bed. We can tilt this vise to hold parts at an angle, clamp it in our main vise. It's very handy. You'll notice that we've got a V-slot machined or ground inside this vise jaw. This allows us to hold small cylindrical parts in a vertical position. When you have a small round part, if we were to clamp it directly in the jaws, you can see we don't have a lot of holding power, if you will. The contact areas that we're gripping with are minimal at best. But if we put it in our little V-block, and we clamp it down, now we've got a very solid, rigid mounting application for this part to be machined. So that's a good thing to keep in mind. Anytime that we can incorporate a V-block into a clamping action for round cylindrical parts, the better off we'll be. These little tool vices are going to run you anywhere from $60 to $100. They're well worth it. They're a very precision-made vise. They're ground parallel within a 1/2 thousandths in any position that you want to set them. So once we have our vise dialed in, this becomes an excellent accessory to hold out-of-position parts for those delicate machining operations. Now let's take a look at a V-block. A V-block is something that you can build on your mill. We'll go into that a little bit later. This is an example of a multi-position V-block. We can hold a V-block in the horizontal mode or the vertical mode in 2 directions. Let's say that again we have a machining operation where we need to hold a part in a vertical position. We simply invert the V-block. Again, it is square and parallel within 2 10,000ths of an inch. We can mount that in our vise. We can clamp it directly to the bed in order to be able to hold this delicate part for machining. We can take a coax indicator, dial indicate this part to get the quill directly over the center of it, offset, do whatever machining operations we want, drill and tap a hole. Another feature, we've got a very fine V-block assembly mounted here on the top. And again, for specialty operations, our clamp will work in that position as well, allowing us to hold that part securely in place. We've got a good solid base that we can grab in the vise or clamp to the table If we had a large flange on the back of this part, we've got plenty of clearance around the bottom end of the V-block. Very versatile combination. Another thing to keep in mind when we're clamping parts in a V-block, we can machine a little bronze disc or aluminum disc as you see here, and this will fit underneath our jam screw, again protecting the part when we tighten it down. We'll show you an application of that. Another good thing that you can use is also a penny. Okay, don't let the boys at the Treasury Department catch you though. You may do in a little bit of set down time for defacing U.S. currency. But a penny or a little piece of brass disc stock that you can run up on the lathe is a very good idea for holding those parts. Now let's take a look at another type of V-block. This is a rather large V-block made by the folks at Starrett. We've got jam screws on the side for holding a large piece of round stock. Again, we're going to use the penny in here on the side to be able to secure the part without damaging the surface finish. We've got a threaded shank here. We can cut a keyway slot in this position either with a Woodruff cutter coming in on the sides, or take our vertical standard mill cutter and mill a slot down the center. Whatever application arises, the V-block is really handy in its repeatability. If we're doing a large production run of parts and we need to have repeatability in a setup, don't overlook the V-block. We can put a production work stop on the end of the part. We'll use this step block as an example. So each time we take a part in and out, we simply slide it up against our stop, secure it in the V-block. We're ready for that second or third operation. Very repeatable. Good idea to have a good set of V-blocks in your tool supply. You'll also see the flanges on the sides. This allows us to clamp it to the bed. We can also clamp it this way in our milling vise. We'll show you more about that later. Now let's take a look at some special tooling fixtures that you can make or are likely to encounter in a machine shop that you're working at. This is a modified V-block that we've machined to hold a specific part. We've installed a dowel pin in the front of it, again, to act as a work stop. If we're doing multiple parts, we simply slide them in the V-block, push them forward against our work stop, secure our screws to hold the part in place, and go ahead and finish whatever machining operation we have on this particular part. We can clamp this to the mill bed. We can run a toe clamp on the ends, on the sides, or we can clamp it in a vise. Again, if we had to hold it at a special angle, our little toolmaker's vise comes in really handy. Just open our toolmaker's vise up, set our tooling block in it. We can put it at an angle if we need to drill or tap a hole or machine a facet on that particular part. So you can see when we have 2 or 3 different tools at our disposal, we've got excellent versatility to hold parts at different angles for different machining operations. Another tool we'll look at is called a sine bar. And a sine bar is what we will use in order to get a desired angle. Here's an example of a sine bar. You'll notice that we've got 2 pins and they're spaced at exactly 5 inches apart. This is a gauge block, if you will, and by putting a shim of a desired dimension or a parallel underneath our sine bar, we can hold or lay parts that we want to machine at a very precise and specific angle. We'll use our machinery guide as a reference for these different cosine angles that we want, and that will tell us how thick of a spacer that we want to put underneath our sine bar to get a desired angle. So this is a very handy tool, something that you can make or purchase. A lot of the machinery supply catalogs every now and then run sales on little sine bars. It's not something you use a lot, but if you're going to be machining and dealing with angles, a sine bar is invaluable. Now let's take a look at another factor that comes into play with machining, and that is spacing the part up and off the table. Let's say that we have our disc again and we're going to need to machine or drill some holes clear through the disc. We don't have a vise, we don't have any way of mounting it other than clamping it directly to the table. We can set a set of parallel bars on the mill bed itself, mount our part on top, come in with the toe clamps on either side, securing our part, and now we're able to drill clear through that part, tap, without drilling into the mill bed. Remember when we talked earlier about purchasing a used machine. If you go to inspect your used machine and the top of it looks like an indexing plate with holes that have been drilled and tapped, the individual operating the machine probably didn't know what they were doing. So this is a neat way to get yourself out of a bind, elevate the part up off the bed in order to facilitate whatever machining operations you have in mind. We also have what is called a 1-2-3 block. These are precision ground blocks that are 1 inch thick, 2 inches wide, and 3 inches long. So anytime that we have a specified dimension or clearance that we need, we can utilize our 1-2-3 blocks in a variety of positions to support our work. Another advantage in the 1-2-3 blocks, again in a clamping application, you can see that we have 3 holes across the top. Depending upon the manufacturer of your 1-2-3 blocks, these can be on both sides. If they are, it's very easy to simply insert a stud through those, clamp it down into the T-slots, and apply direct clamping pressure over the top of our 1-2-3 block. Now, let's move on to my favorite work holding device, and that is the mill vise. Give me a few minutes to get the mill cleaned off, and I'll join you in just a second.